my session in the last class. So luckily, some of your friends have. I hope you are all able to see my presentation. Say yes or no. One of you can unmute and speak to me.
Yes, sir. Visible, sir.
Yes, okay. Sine, transducer is actually a device which is trying to convert one type of physical variable to the other form, and the preferable conversion form it is actually trying to do into electrical voltages. The advantage in getting it in the output form as electrical voltages, it is easy to measure as well as to for evaluation, and that can even be interfaced to the computers for recording purposes. And of course, sensor, when you try to refer, that is trying to sense the output in the form of physical variable. Say transducer is actually trying to convert physical variable into the other form. Sensor, what it is trying to do is that transducer input it will take and it will try to give us the exact measurement. That physical variable could be force, pressure, acceleration, whatever it is. And of course, even the velocity, all those things comes under that particular one itself. And since you are trying to use these transducers extensively, those things have to be calibrated properly. If it doesn't calibrate properly, we may not be able to use it at the exact situation. Say, for example, you are trying to fill some content by a certain quantity. If your jar, what you are trying to use to fill, maybe you try to consider petrol bunks. There is a reading that is going to show the unit quantity and the price. If that was not calibrated properly, say it might be giving excess quantity out, or it might be giving lesser quantity than the specified. If it gives lesser quantity, then for the price you are paying, you are not going to get the quantity. Okay, so the amount whatever you are going to pay is going to be on the higher side. That way it is going to be something like that. If you try to realize, even in this particular situation, the transducers and the sensors should be calibrated properly, and that particular calibration is being done with a relationship between measured variable with respect to the output signal. Means physical variable what you are trying to quantify with respect to the output signal, that relation should be established. And sensors are trying to provide interaction with the environments in a flexible manner and in an intelligent manner. So it is something like flexible in the sense whatever you want you can measure. See, if you want pressure you can measure. If you want velocity you can measure. If you want force, that you can measure. Such a kind of flexibility is associated. Maybe based on the data it has been extracted, you can give some prior preferences. Say, if the pressure is so much, do this. If the pressure is so much, you do that. Likewise, you can incorporate certain changes. You can instruct certain actions against the data being collected. And suppose the robo, if you whatever you are trying to prepare, if it has been accommodated with the see and feel, all that is actually possible by accommodating certain sensors. With those sensors, if you can make that to see and feel, then it will be easy for us to give certain instructions. Like, see, if you see this, do this. If you see that, you do this. Like we try to give instructions for the kids, and even for you sometimes when we see you behaving like this, better not to do like this and all. We try to tell you a sort of correcting mechanism or a set of mechanism looking at your actions, what you should, how you should be, a sort of suggestions only we try to give. Whereas for a robot, if it can see and if it can feel, Based on that particular kind of data, whatever it has saw and whatever it has felt, you can give some kind of instructions, pre-derived instructions you can give. That is how you can train your robot. So once you are able to train your robot on those grounds, you will be able to use that particular robot to handle complex tasks even. In your mechanical measurements content, maybe DS Kumar, if you try to open, the first page itself was trying to give you so the list of sensors and the physical variable that is possible to measure with this optical. Very few out of them have been listed out here. Strain gauges that can be used to measure force and pressure, thermocouples being used to measure temperatures, speedometers for the measurement of velocity, pitot tubes, flow rates, likewise. Based on the type of converted signal from transducers and sensors can be broadly classified into two groups: contact type, okay, analog type and digital type. Analog type and digital type, the way in which the output is going to be visualized. If that has been got in the form of analog, okay, that is going to be referred under analog. Then if that particular value is coming in the form of digital signal, digital output, that is going to be referred under digital type. Maybe the sum of voltmeters and ammeters, okay, voltmeter and ammeter having some kind of needle, and that needle movement, if you try to refer, temperature indicators also, if you have a needle that is trying to point towards a value, all such things are going to be referred under analog type. Okay, analog transducers provide a continuous analog signal such as electrical voltage or current. This value can be interpreted as a value of physical variable. And coming to the digital type, digital transducers produce a digital output signal. Digital transducers produce digital output signal. Analog thing produces analog signal as an output, preferably in the form of electrical voltage or current. And later on, we try to attach some conversion mechanism in order to show the required temperature or required pressure, whatever it is. Signal in the case of digital type is going to be either in the form of parallel status bits or series of pulses that can be counted. Okay. Anyway, nowadays digital type thing is becoming a popular because you are able to read the data directly. The moment you have got the data from the sensor, you would have given further instructions to do what to do next. That is how it has become popular, in particular in the automation and process control. And of course, there are certain characteristics that has to be followed by a particular sensor, okay, or the features: accuracy, precision, operating range. Accuracy should be as high as possible. Once a particular sensor is actually capable of giving a reading with high accuracy, means that average error is going to be bearable minimum, and it will try to reduce to, you are trying to bring down that to zero. It is impossible to reduce that particular error to zero, but you are trying to bring down that particular value to zero. Okay, then precision should be as high as possible, so that once you have got precise value, so that the dispersion, its deviation in the series of values when a measurement has been taken, and that particular dispersion is going to be as minimum as possible. Then coming to the operating range, it should have a high operating range. See, you all by now are habituated to use thermocouples, thermometers, or even thermocouples. See, a thermocouple, what normally being used for positive values, will not generally be put in use for negative values. We would have experienced that in the case of heat transfer laboratory, I believe, wherein there are negative value is going to be there in the case of refrigerator. That value we will be able to measure with the support of thermometer. The range of that particular thermometer is going to be very small when compared to the other thermometer. Say whatever the thermometer you try to take, you will be able to measure say up to 120 or 130 or so. If I want to measure a value higher than that, it is not possible. And that technique itself is not possible to use. We will go for the other methodology. Okay, so taking into account all the aspects of measuring range, uh, a setup or a device or a sensor which is giving us a scope to measure the values in a wide range is being taken into consideration. That too, you should also take into account within that particular wide range is the accuracy is good or not, and the precision is again good or not, and the validity of those values with respect to the accuracy and precision within the range you are trying to use, that should also be taken into account. Then coming to the speed of response for a given input, maybe the sensor you would have used to sense a particular variable, say temperature or pressure, how much time it is going to take to show the value is being taken as the speed of response. That should be as high as possible. Means time whatever it is going to take for showing that particular variable value should be as minimum as possible. Otherwise, what might happen? Say you have inserted a thermometer, temperature would have showed at an instance maybe 98.6. The actual reading would be 100. For that, if you have inserted that particular thermometer for a quite long period, only then it might be giving you the value of temperature. It might be doing like that. Okay. Then what happens? In a given span of time, the value whatever has been read has not been correct value. Your decisions based on that are going to be wrong. If human body, if its temperature touches 100, it means that there is some rise in the temperature of it. Based on that, you should be in a position to go on looking for the reasons for that. So this is a simple example I wanted to tell you. On the other grounds also, say there is a what you call process happening. You wanted to maintain the temperature of that particular process. If it shows that particular value on time, then there are going to be necessary actions that need to be taken based on that. So all those things are possible when you have a sensor which can show the value, which can sense the value within the minimum stipulated period of time. And of course, calibration when it comes to, we have already seen in the earlier discussions, we should be in a position to calibrate that particular variable easily. So for example, you have linear variation of that particular variable, easy to calibrate. You have non-linear variation, not going to be that easy to calibrate. And you are going for high ranges, for a particular range linear, for some other range that linearity may vary. Linearity in the sense slope value. That slope value for a particular zone of range might be something. For the remaining zone of range, it might be something. So all those things are going to matter a lot. And moreover, we feel that the accuracy of sensing is going to be reduced in its usage. So accuracy of that particular sensor is going to go on reducing with respect to time. And that particular aspect should be, that reduction should be as minimum as possible. Say for example, you have tried to attach a sensor to measure velocity. On its period of its usage, the actual velocity may be something and original velocity, maybe the velocity being sensed is going to be something, then that is going to create problems. Okay. Then reliability. That value being sensed should be highly reliable. Okay. So moreover, it should not undergo any sort of failures during its operation. Say for example, I am trying to measure some property, maybe force. Keeping that particular aspect in mind, I am trying to put in that particular robot in its usage. If that sensor fails, I will not get the scope to get the actual value of force. Then I will be under the assumption that it is actually going ahead with the same force, but it has failed and it is not showing the actual value, or it might not even be showing the value at all. So that is going to create a problem. So that is the reason the sensor, whatever you are trying to use, that should be highly reliable and it should not experience frequent failures. Cost and ease of operation. The procurement cost, it could be manufacturing cost, it could be installation setup, it should be, and operating the sensor, whatever you say, all those things should be with bearable minimum expenditures. Okay, then should not demand for specially trained and highly skilled operator. Say for example, there is a BP operators, there is a what you call glucometer. You doesn't need any skilled labor for it. What you need to, you should know the procedure of handling them. Once you know the right procedure of handling them, everyone of you can go on using that. Okay, something like that. Then coming to the sensors used in the robotics are mainly for the interaction with the environment. So this particular statement has already come earlier. Again, I am trying to stress it again. This is looking at the importance of it. It has been stated again. Sensors that are used in robotics are mainly meant for providing interaction with the environment. It could be anything. It could be anything. Usually, they perform the following functions: detecting the motion control variables, guiding the robot without obstruction, objects identification, objects handling. These four are the major tasks. Okay, so in order to handle these tasks, robot is trying to take the support of sensors. Maybe the interaction with the environment have been basically provided on a need basis. That necessity was subgrouped into these four categories. That is detecting the motion, guiding the robot, objects to be identified, and objects to be handled. Objects to be identified, if you try to consider, suppose I have devised a robot to handle this particular object, say. By mistake, in place of this, I have kept this. If it is this, weight of this is something. If it is this, weight of this is something. Shape of this is something. Shape of this is something. So keeping these aspects in mind, your robo should be capable to identify the objects it is trying to handle. It should confirm. It is something like you have tried to apply for passport. They try to do verification for what? Whether in order to confirm it is you who has applied for passport. Only then they are going to issue. Even here, before that object has been handled, it is going to confirm that this is the object what it should handle. Okay. Anyway, those are the things what have been taken into account. There are few more varieties. Internal state. So the sensors that are all being attached to that are going to sense the information. based on the internal arrangements. So that is trying to provide some kinds of information like joint position, like angles, and velocity that has been, rather with which the joint has been made to move. So these position and velocity sensors, which are all trying to give the informations with respect to the joint, and those things have been referred under internal state sensors. Then coming to the external state sensors, there are two types under this. One is non-contact type, another one is contact type. On non-contact type, these are the sensors that guides the robots with the help of vision and range sensors. So with the support of camera being attached, it is going to sense the object. Once it has been sensed, based on that, the conclusion is going to be derived. Range sensor, say one end effector has been made to move close to the object. So with what distance that object is, that range sensor helps the robot to identify. Okay, based on that, the activation and deactivation of your what you call fingers or end effectors are going to be. So those sensors are actually not bothered about the contact. Okay, so that is why they have been referred under non-contact type. Then contact type, proximity also, as I may be okay. Some portions of explanations I would have gone wrong. I will rectify them. Okay. Anyway, coming to the external state sensors under contact type, under that contact type, these are the sensors that identifies the object with the support of proximity and touch sensors. So it is going to touch and sense what type of object it is. Sensors that provide the information regarding the object handling with the help of force and torque sensors. Even these sensors are going to come under contact type sensors. So when you want to measure the force, when you want to measure the torque, even for that, you are going to take the support of sensors that are going to have maintain physical contact with the object. And anyway, same information has been represented in a pictorial format. Say altogether robot sensors, they have been grouped into internal state type, used for robo control, because okay, that has been used to detect the arm position, velocity and acceleration. So the sensors that are all trying to detect the position, velocity and acceleration, they are all being referred under internal state type. Then coming to the external state type, these are basically used to guide the robot as well as for objects identification and also for objects handling. Under this, you have got non-contact type and contact type. Then coming to the non-contact type and contact type, under non-contact type, we are going to get proximity sensors, range sensors, range and vision sensors. Okay. Then under contact type, we are going to get touch sensors, slip sensors, and force and torque sensors. The information being recorded in this particular plot is actually correct. Maybe some deviation I have noticed in the last before slide that I have to correct. Maybe in the slide number 9, some information being represented over there is not observed to be good, but the information whatever has been reported here in the slide number 11 is okay. Now what purposes that are going to be served by range and vision? These two sensors are going to provide overall guidance for the robot. And coming to the proximity sensors and touch sensors, that are trying to deal with the last stages of object grasping. Object you wanted to grasp, before that has been grasped, you are going to sense that. And that particular sensing is being done with the support of proximity sensors and touch sensors. And coming to the slip sensors and force or torque type sensors, they are trying to provide the feedback for post grasping as well as for manipulator control. Say for example, I am trying to handle this. If I press more, the object is getting pressed. This is actually being expandable type. It is not going to create any problem. But with the support of touch and rather force and torque sensors being attached onto that, we will be able to see what the volume of quantity of force that has been applied to this. That we can see. Maybe if you feel that that force being applied is more, then we can draw a conclusion to say that that can be brought down. That can be reduced. Okay. That entire information we showed in the slide numbers 10 and 11 have been grouped together and that have been kept in the single slide. I'm sorry. Let us move to the position sensors. Let us move to the position sensors. Position and velocity sensors are used as feedback devices in robots. It is something like, suppose you have given an instruction to move the robot. That instruction will go to all joints. So when it has been instructed to move, I'm sorry, I'll be talking about this particular slide. I'll move a bit and come. Okay. So when you have given an instruction to move your robot in the car, that movement is going to be happening, or that is going to take place at all joints which are associated to that particular robot in the car. There may be 2 joints, or there may be 3 joints, or there may be 4 joints, whatever it is, irrespective of the types of joints. Because you will be, with the support of sensors, you will be able to know the initial location of them and the final location of them. And as per your knowledge, you are going to give the instructions to travel with certain velocity. Okay. So with that velocity, it would be moving, and that time your sensors are again going to sense. So it is something like this. You would have given some input signal and it is time to do something, and that doing is what you should know that is going to be set through our sensors being attached to that, and it senses all that information and it sends as a feedback signal to us, and that signal at the other detector location, the input and output, both the things are going to be compared. So that is a corrective action that has been taken in order to ensure that the robot, whatever we are using, have been instructed to follow our instruction to the maximum possible extent. Then these are basically used to measure linear and rotary displacements. Position sensors, say x1, y1, z1 at one instance, x2, y2, z2 at the other instance, the shortest possible distance between them, if you try to refer, that is nothing but the line joining. That if you do, the movement is going to be linear. And x1, y1, z1 and x2, y2, z2, that might be possible for us to achieve only through rotational movements. Even that is possible to measure with what angle that has been displaced. is going to come as an output, as a feedback. That feedback is going to be compared with the input, and that is how the error signal is going to be generated wherever required. These are majorly used to control the position of the arm. That is obvious. Once you know these values, you are going to compare them with the input values, and that is how you are going to, what do you call, control its position. Like that feedback is going to be used to move further. That way you can vary. Potentiometers, resolvers, and encoders are commonly used as position sensors. Potentiometers are not new for you. That uses Wheatstone bridge. You have already come across this in your earlier or rather pre-engineering course. Would be at your intermediate, or it would be even at it would have come to you even at 10th class or so. Resolvers and encoders are these three are some of the sensors that have been used to measure the positions. Now let us move to the potentiometer. Let us move to the potentiometer. I'm sorry. Any disturbance? I'm sorry, somebody has unmuted his mic and he is trying to make all of us to listen to the crow. He might be he might be taking care of a crow. That crow interactions he is trying to show, make us to listen by all of us. Anyway, potentiometer, when it tries to, potentiometers provide the most straightforward form of position sensing. That you can see here. This is linear, this is rotary, dimmerstat or variac. Based on the contact position you are trying to maintain, the resistance is going to vary. So resistance and length of that particular one are directly proportional. That has been taken into account. That relation has been taken into account. So it could be a linear one, variac, okay, rheostat. It could even be a dimmerstat. One will be having a rotary switch, another one will be having a linear switch. You can vary literally on that resistance. They produce output voltage proportional to the position of the wiper. This is what is actually the wiper in this case. That wiper will be maintaining contact. See here, one end of this has been connected, other end is actually being connected through the wiper. Even here it is actually happening like that only. It was not showed. See, this is the end being connected to one end, one terminal. This is being connected to the other terminal. This is actually trying to give you the output voltage. Okay, so here these two differences are going to give you the output voltage. The figure illustrates a typical pot in the sense potentiometer. First three words, first three characters of a potentiometer is actually pot that has been. Potentiometer may be linear or angular. Okay, potentiometer can be linear or angular. You can put in your own words. Say this entire thing is a resistor. Total resistance is actually R. This end is actually being connected to one end, maybe power source. Then the wiper can be moved from this location to this location. Maybe here it has been showed as A. The other end you can label it as A dash or B. From B to A, the wiper can be made rotated. If it is at B location, the power is being shot. When you go on moving the wiper, the total resistance is actually this. You are trying to reduce the resistance. Accordingly, the output voltage is going to vary. Same is happening even in this. So likewise, you may kindly put it in your own words. So this is your encoder. This is your encoder. Maybe if you try to see this particular encoder, anyway, it has got a circular disc having some slots, transparent slots alternately. That too, they are all equally distributed. Now in this particular figure, this vertical rectangular piece, if you refer, that is your piece of this. So this piece is this, and you have got a light emitting source here, and you have got a photo detector. So now this particular disc is mounted on this shaft. When this shaft has been rotated, the disc also rotates. When this disc rotates, and when the light has been made to pass over through this disc, there are alternately slots. Whenever the transparent portion comes, that light source travels. Then whenever the obstruction comes to the light source, that will not travel. So whenever the light source has traveled through the slot that reaches the photo detector, it catches up that as an input. Then that information is going to be amplified, and that is going to be sent to the counter. Same information has been stated here. The encoder is a sensor attached to a rotating object such as a wheel or motor to measure rotation. Encoders are used to measure displacement, velocity, acceleration, or the angle of a rotating sensor. An incremental encoder consists of a disc marked with alternating transparent and opaque strips aligned radially. So this is what is of that particular way. Maybe you are going to come across two types: incremental encoder and absolute encoder. Okay, that entire procedure has been listed. Photo transmitter is located on one side of the disc, and a photo receiver detector is on the other side. Light beam output shaft. In order to find the direction of rotation, two sets of photo transmitters and photo receivers are placed at 90 degrees out of phase. See, uh, maybe with this straight configuration, we may not be in a position to know the direction of rotation. In order to know the direction of rotation, photo receivers are two sets of photo receivers are placed at 90 degrees out of phase. Okay, so the idea is, say suppose you have a slot and you have a photo detector here. Now followed by you have got a non-open slot, means obstruction is there. Now this is one set. Another set is going to be offsetted by 90 degrees such that even if this one rotates, disc rotates, when one time through one set, that photo beam is going to be made to pass through. Simultaneously in the other set, photo beam is not going to be passed through. So that way they have been accommodated. That way you try to imagine. In order to take the accountability of direction of its rotation. And of course, the absolute encoder, if you try to consider, it is not going to bother about the starting position. So the basic difference between the absolute encoder and the incremental encoder is, incremental encoder takes into account the starting position. Absolute encoder doesn't bother about the starting position. Okay. So the working construction and working procedure is same for both the types. More number of strips corresponding to the number of receivers and transmitters are found in this. That kind of figure has been shown in the next slide. See here, these are all the slots, transparent slots. Earlier thing was actually showing only one radial slot, and those such slots were distributed radially. That is what is the kind of sketch what we have seen. You can see here in a radial direction itself in this figure there are 5 slots, means 5 light sources are there, means 5 receivers are also there. Okay, so this particular disk is going to have so many slots like that. Okay, now you can see here many more. Why that has been kept like this? See here, let us see this, how it has been done. This has been labeled as 2, 2 power 1, 2. Then the next one, okay, 2 power 2. The next one, 2 power 3. The next one, 2 power 4. Likewise, slots being arranged in a particular periphery, based on that you have gone. And based on this number, only the angle precision we are able to. 360 degrees divided by x. What is this x? Range. That range, if you key in over here, 360 degrees divided by range, if you key in, that is going to give you the angle of precision. Okay. Anyway, so when you try to see at the receiver end, there are going to be inputs either in on mode or in off mode. Okay, on mode in the sense 1, off mode in the sense 0. Position sensor encoder with the support of optical shaft. See, you have got a DC motor, you have got gearing. This is your robo joints, arms. So, based on the movement of the arm, that is going to move this particular gearing. That is going to move this particular DC motor. And that is going to give an input to the optical encoder. You can see, even here, slots are there. You have got emitting diode. You have got what you call sensor, and that particular receiver will try to receive the signal like this, because in whenever for this particular emitting source, whenever the slot is there, that time on means 1. Whenever the obstruction comes in between, that time off, that means 0. So this is for 0, this is for 1. Okay, so I think I need to stop at this end. I need to stop at this end because we have already reached 11:46. I'm still stopping the share screen. I'm also stopping the record. Stop recording also I'm pressing.